So we have said we open circuit the current sources, we open circuit the current sources and short circuit the battery sources. So what I do, I have my battery source here, I remove it, I connect all these ones. Remember, I need to open circuit. So what I mean, I have open circuited the rest, so I need to short circuit the battery source. What happens? So we need let me see. Okay, let's first look at maybe the resistance of this circuit. So what happens when you look at it, when you come here you select the ohmmeter, so that means it has become an ohmmeter. So if it is an ohmmeter, you run, when you run it, it gives you about 2.157 ohms. But we need to readjust it because remember our circuit looks like this. We have when we short circuit here, there is something different that happens. You remember that you remain with an open, I mean with an empty, just a bare wire, which means the current, if for example current is flowing and it meets a resistor and a bare wire, it will just flow through the bare wire. So that's why I'm saying this result is not reliable. But let me see if we can create a bare wire here, or just a single wire. Okay, maybe let me simulate this using let me simulate it using a switch. So let me just rotate it. Let me bring back my multimeter. So I'm going to connect it here and there. So what do? I'm going to press this switch is closed by key A. So if I press A, it will close. Why am I using this? It's because I'm unable to access just a single wire to connect it here, so that I'm able to represent a short-circuited battery source. But using this key, I'm able to simulate that. So if I open it by pressing A, it becomes open. Let me first simulate it and choose ohmmeter. So it is still giving us the other result because we haven't closed here. So let us close. Let us first stop and then close that. Then we run. Okay, so there it is showing us 0. That means we have placed our ohmmeter in a wrong direction or in a wrong position. So what we do, we come back here and we move our ohmmeter this side. So the resistance will be as you look through the circuit, but in this position. So I'm going to bring my, okay, let me connect that. Let me connect this positive to here and the negative to the ground. So this is an ohmmeter. So let me run. So ladies and gentlemen, this should be our right result. Why? Because we have successfully created a short-circuited battery source. So when you look at it, let me see if we can use a calculator very fast. You will see that you have, for example, the 10 and 4. Let me say they are in series with each other, okay? Then in parallel with the 2. So what does that mean? You will have 14 times 2 divided by 16, and you get 1.75, which is in series with it's going to be in series with a 1. Let me see if it comes out. Plus 1. I will have 2.5, but which 2.5? Remember, when we are just assuming that the current maybe is flowing through this. Okay, let me see if it flows through this. This would be a 10. Okay, let us assume it like that. We say is flowing through a 10. So when it reaches here, it goes to the 2 and maybe comes back to the source, then it continues. So when it reaches here, it does not flow in the 10. Actually, it will continue in that direction. Then it comes back. So that means the 10 is going to be okay, the 1 and the 2 are going to be in parallel, so that maybe, let me see, we have 2 times 1, which will be 2 divided by 3. So now we have a 10 which is in series with a 0.6, so plus 10. And now what does that mean? Let me see what has gone through the 10. Okay, so it means what has come will be in parallel with the 4. Let me see, times 4 divided by 14. So if I do it like that, I get 2.908, which is approximately equal to 2.909. So that means my assumption is right, that if I'm looking for the resistance here, it is going to be like this. The 10 ohm resistor is going to be in series with this parallel combination. In other words, I'm assuming that current is coming through the 10, it divides here and goes through the 2. So the one that goes through the 2 flows back to the source. Then the one that goes through the 1, it will not, there is no current that is going to pass through the 10 because there is 0 resistance here. So that means the 2 and the 1 are in parallel. So the 2 and 1 being in parallel will give you a 2 times 1 divided by 2 plus 3, which gives you 0.67. So that is 0.67 plus 10 will give you the resistance along there. Now the current that passes through the 10.6, when I add the one that goes through the 4, okay, it will give you the total current that is flowing back to the source. So that's why I'm saying the 10 plus 0.67, let me say 10 plus 0.67 gives you 10.67. So being in parallel with the 4, so the effective resistance will be 10.67 times 4, now divided by 14.67. So it gives me 2.909, and that means we are correct. So ladies and gentlemen, I don't know whether there is any question, but that is how you can measure resistance in multisim using a multimeter and by selecting the ohmmeter. So thank you so much for listening, and if there is any questions, please bring them forward.